Okay, class, I'm going to try very poorly to redo this and hopefully it saves us time. So, welcome back. We're going to be talking today about lesson one, solutions involving one and two step equations. We already went over in class these definitions. I'm just going to go over them again. By the end of this video, you should be able to know what an equation is and what it means to do when you're asked to solve an equation. You'll know what the balance method is for equations and how to use it, and you'll know how to solve both one-step and two-step equations. So we're going to start off with what is an equation. An equation is two expressions that is set to equal each other. So the example that we did in class together today was really simple. We said an equation. I also want to just point out, I actually write equations sometimes like this. So I sometimes write equation or equation, right? Both of these just means equation. It's just a short form that I use, and some of your other teachers will use this as well. So with that being said, we're just going to move on. And one thing I really want you to be able to take away from this lesson is know the difference between an equation and an expression, right? Because they're not the same. So expression and equation, right? And the reason I say that is because something like 2x plus 4 is an expression. Something like x plus 5 is an expression. When I take these two values and I make them equal each other, 2x plus 4 equals x plus 5, that's when this becomes an equation. So an equation is something that is two expressions and then you put an equal sign in the middle and now they are an equation. And I can solve for x and x will only have one possible answer. The goal when you're solving an equation is to determine the value of the variable that makes the expression equal. So what value for x will make this expression true? This means that we need to determine the value of the variable that makes the equation a true statement. So in order to do this, what you need to do is have the variables with the coefficient on one side, and with the other side, you're going to have the numbers on the other side of the equal sign. Whatever operation you do to one side of an equation, you must do to the other side of that equation. This is what we call the balance method. The balance method just means that we can use opposite operations, or in our operations, just like this is a language, are plus minus and multiply and divide, right? So those are operations. To isolate or solve for the variable. So when I'm asking for isolating, right, I want the variable on its own. So these are two things that we can be asked when we're asked to solve an equation. Okay? So moving forward, we did this in class today. I'm just going to go over it again with you. So if we wanted to find out how many candies are in this bag by itself, we're going to use this balance of a scale. So how I like to think of it is that this middle portion, the fulcrum, is the equal sign, right? When we're solving equations, how you would go about doing this is you know that there's two candies here and there's some unknown number in here. A good way of figuring out how many candies are in there is you take off these two candies from here, because I'm only interested in what's in the bag by itself. So I got rid of those two candies. Now, if I got rid of these two candies, this balance is going to move downwards this way. So in order to figure out what's in here by itself, I need to remove two candies from here, and then I also need to reduce two candies from here. Because whatever I do to this side, I have to do to this side in order to keep it balanced. So what this looks like as an equation is that you had some amount of candies in your red bag plus two candies outside is equal to, there's 1, 2, 3, 4, 5, 6 candies over here, right? I'm just going to substitute this question mark with the variable, so I'm going to use x, plus 2 equals 6, right? Then what I went and did was I did x plus 2. I want to get this candy bag by itself, so I got rid of those two candies on that side. But in order to keep a balance, I also got rid of the two candies on this side. Plus 2 minus 2 is just going to be 0. plus x, right? Because I still have that candy bag there. And then I got rid of 2 over here, so I'm going to do 6 minus 2. So I'm just going to do that in my head, and I'm left with 4 candies. When you have a plus 0, you never actually need to write it in, so you're just going to leave it as x equals 4. Now I know that there's 4 candies in that bag because when I balance everything out, I'm only left with 4 on this side. And that means there's probably 4 in here. We're going to do the same thing with a multiplication. So now we know there's 1, 2, 3, 4, 5, 6, 7, 8 candies on this side. And there's 2 bags on this side. I'm only really interested in what's in one bag, right? So we have 2 bags of candies. They both have the same amount of unknown quantity of candies in them. And they're both equal to, when you multiply those together, they're equal to 8. 8 candies altogether. I'm just going to replace this question mark with an x equals 8. Now, if I wanted to know how much candies were in that bag, I know that I need to distribute these candies evenly. So I'm going to put 1 in here, 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 right? Or another way of looking at this is very simply as I have 8 candies and I have 2 bags. If I'm having 2 times x, I'm just going to divide that by 2, and I'm going to divide this by 2, so the opposite operation. I'm going to get x equals 4. Okay? Because whatever I do to this side, I got to do to this side. If I'm going to take off this candy bag, I got to take off 4 of those from that side as well. All right. So moving on. We're just going to go through and do this together. So when you want to solve for x, you want to isolate for x. You want to get this x on its own on one side of the equation. So if you want to solve for x, to isolate for x, you need to get rid of the 5. You need to get rid of the positive 5. How do you get rid of a positive 5? You add its opposite integer, which is in this case, the opposite of positive 5 is just negative 5. And whatever you do to one side, you have to do to the other side. Another way of looking at this is you could have said you just subtract 5. Either way, I will accept. Because a positive and a negative is equal to a negative. Same thing here, positive and negative is equal to a negative. So plus 5 minus 5, we got rid of that. So you'll have x is equal to 17 minus 5. And you know that is, sorry about that, just getting some water, 12. Okay? And that is how you do that one. So if you're listening to this and you're watching it for the first time, I would suggest try doing the next one by yourself. So pause this video for now and you can go and try to do the next one by yourself. And then when you're ready to do this, because you've already done it, come back and unpause the video and you can watch the solution. All right, so welcome back. What you're going to do is you're going to do the next one. So in order to solve for x, you need to get x alone. So you need to get rid of the negative 8 by adding its opposite integer. Okay, so then you have x minus 8. The opposite of minus 8 is plus 8. Whatever you do to the left side, you got to do to the right side. So you add plus 8 there. Minus 8 plus 8 cancel each other out. So you'll have x is equal to 6 plus 8, which means x is equal to 14. Getting a little bit more complicated because the negative 5 is the front, but really it's not that much more complicated. In order to get rid of the negative 5, you'll need to add its opposite integer, which is positive 5, which is just the opposite of what we did up here with the positive 5. We added its opposite integer, which was negative 5. Right, so I'm just going to go in here. Negative 5 plus positive 5 plus x is equal to 6. Whatever I did to that side, I got to do to the other side, plus 5. These two cancel each other out, so I'll have x is equal to 6 plus 5, which is just 11. Okay. Now this is where it gets a little bit more complicated, just because we were multiplying and dividing. So something that's important to recognize is that multiplication and division, much like addition and subtraction, are the opposite of each other, right? So when you're multiplying something like 2x, realize that you're multiplying. You can't just do 2x minus 2, because you can't get rid of this 2 by just subtracting. You're multiplying it. Okay? So the opposite of multiplication is division. So to isolate for x, what you're really going to do is perform, I'm just going to write that in, perform the opposite operation to isolate the variable. So what you're going to do is, if it's multiplication, you're going to divide. So you're going to take this 2x and you're going to do 2x divided by 2 is equal to 14 divided by 2. These 2's will cancel each other out. And if you want a further explanation on why this happens, I can make a video for you as well. And then you'll have x equals 14 divided by 2, which is just 7. And that'll give you your answer. You're going to do something similar. If you want to solve for x, you're going to isolate x by performing the opposite operation, division, to isolate with the negative number. Right? So if you're going to divide here, you're multiplying it by -4. So it has to be divided by -4 as well. So I'm going to go in here. I'm going to say divide by -4. Divide by -4. -4 divided by -4 is just going to be 1. So I'm going to have x is equal to 16 divided by -4 is -4. And that's my answer. So in this case, we have something that's actually starting off as a division. So you have x divided by 2 is equal to 9, right? So you want to solve for x. How you're going to solve for x is to get x alone, you're going to multiply, which is the opposite of divide, by both sides. By 2. So what you're going to do here is you're going to take x divided by 2 multiplied by 2 is equal to 9 times 2. I always like to put stuff in brackets because that's best form. So you have x, you can cross these 2's out, x equals 9 times 2, which is 18. Okay. So the biggest takeaway I want you to take away from this is, and I'm just going to highlight it down here, is when solving equations, always use balance method. I know some of you might have learned the bridge method. Do not use that here. We don't use that in grade 9. And it'll just confuse you. So we're saying it less so for now because it works for now, but it won't work when you get into more complex functions. So I would just say get into the habit of using this method now. Okay? So when we're going to solve two-step equations, it gets a little bit more complicated in that situation. right? So you have something like 2x plus 8 equals 20, right? The first thing you're going to want to do is get this 2x on its own, right? We want to deal with the addition and subtraction first in this situation because the division is actually more complicated. So first thing I'm going to do is I'm just going to get the 2x by itself. So I'm going to say isolate 2x by adding negative 8 to both sides. Right, so I'm going to take 2x plus 8 minus 8 to get rid of that 8. And whatever I do to one side, I got to do to the other. So it becomes, oops, this is minus 8. 2x plus 8 minus 8 cancels out. 20 minus 8 is equal to 12. Right? And to get the x by itself, you are going to divide by 2. Divide by 2, so divide by 2, right? And x is equal to 6. And that's how you do that. Okay, so we're going to move on, right? And go on to doing more practice. So try these ones by yourself and then you can come back and watch the solutions. All right, so you're going to isolate 3m by getting rid of by adding positive 13 on both sides to give negative 13 plus 3m is equal to 2. So I'm going to add positive 13 here. Right, positive 13 minus 13 is going to give me 0, 3m. And I'm going to add 13 here. So 2 plus 13 is equal to 15. And then I'm going to isolate the m, this should say m, by dividing both sides by 3. I'm going to divide by 3, and then I'm going to get m is equal to 5. Similarly, we're just moving on, and now we're using, instead of positives, we're going to use negative numbers. So you have 12 minus 5x is equal to negative 8, right? So first things first, I want to get rid of this 12 over here. So I'm going to say 12 minus 5x is equal to negative 8. I'm going to make sure I put a negative 12 on this side too. Cross those out. I'm going to have minus 5x is equal to negative 8 minus 12, which is equal to negative 20. Right, and now I want to get rid of that negative 5, so I'm just going to divide by negative 5. I'm going to divide this side by negative 5. Cancel, cancel. X is equal to negative 20 divided by negative 5. So I'm going to get rid of that negative sign, and it's going to be positive 4. So last thing that we're going to do is you can actually, the one thing I really, really like about solving equations is that you can actually check your answers to make sure that you got them right. So how can you check your answers? So say we do D together, right? We're going to find D just using the balance method. So I have x divided by 2 plus 6 is equal to negative 8, right? First things first, I'm going to get rid of this 6 over here, right? I'm going to get rid of it by adding negative 6 or just subtracting 6 equals negative 8. Whatever I do to one side, I got to do to the other, so I got a minus 6 on that side. So I'm left with x over 2, positive 6 minus 6 is 0. Negative 8 minus 6 is equal to negative 14, right? Now I have this 2 at the bottom, so I want to get rid of it. So this is x divided by 2. The opposite of division is multiplication, so I'm going to do multiplied by 2. So I'm going to get rid of that. Whatever I do to one side, I got to do to the other. So I have x multiplied by 2, which is equal to negative 28. So I know that x is negative 28. Now that I know it's negative 28, how can I check this? So I'm going to check it with orange, right? And how I'm going to check it is I'm just going to go back and plug this negative 28, which I know what my x is equal to, into the equation and see if it's true. So I like to always set it up as left side and right side, right? Right off the bat, we already know what our right side is going to equal. It's going to equal negative 8. Our left side is equal to x over 2 plus 6. I know that my x is negative 28, so I'm just going to go in and put that in. Divided by 2 plus 6. And I'm just going to solve this. Negative 28 divided by 2 is negative 14 plus 6. Negative 14 plus 6 is negative 8. Now I know that my left side equals my right side. So I'm just going to write left side equals right side. Therefore, equation is true. And that's just a great way to check your work. This might seem tedious now because the numbers are small, and it doesn't really matter that much in grade 9, but it will start to matter to you when you get into grade 11 and 12, when you have a little bit more complex problems and you want to show that both sides are equal to each other. Okay, so we're going to do the same thing. Again, if you're watching this video, whether it's before or after class, try E by yourself, right? Try it by yourself. See if you know how to do this. See if you actually understand it. And then, so just pause the video here, try doing it by yourself, and then come back after. So I'll give you a second, pause. Okay, welcome back. I'm going to take that you actually did pause the video. So I'm just going to do 2 divided by 3x minus 4 equals 10. So first things first, we're going to solve this problem, right? So you're going to do the 4, you want to get rid of that first. So minus 4, just add 4 to get rid of the minus 4, equals 10. Whatever I did to that side, I have to do to the other side. So I have 10 plus 4. I'm going to have 2 divided by 3x equals 10 plus 4 is 14. Right, 2 over 3. I want to get rid of it so if I'm doing x multiplied by 2 over 3, what I'm going to do is I'm going to do x divided by 2 over 3. So there's 2 ways that you can do this. I'm going to show you the way that I find the easiest first, and then I'll go back and do the other way. The way that I find the easiest first is right now I know that this is 2x, and I just like to visualize it like this. It's 2x over 3, right? So right now, everything is over 3. So what I'm going to do is I want to get rid of that 3. If everything's divided by 3, if I just multiply both sides by 3, I can get rid of the 3. So I'm left with 2x equals 14 times 3, right? And that is 42. And now I want to get rid of the 2, so it's 2 times x, so I can just do the opposite. Divided by 2, divided by 2, right? And then I'll get x equals 42 divided by 2, which is just equal to 21. Personally, I hate working with fractions, so when I can avoid them, I do. I just change things into whole numbers. This is up to you if this is the way that works for you. If you would like to do it the other way, which I'll show you on the side over here, right? And I'll just highlight that for you. And I'll put it in a different color. I'll put it in, let's put it in orange. Or what you could have done was you could have done up until 2 over 3. You could have had 2 over 3 x, right, equals 14, right? What you could have done was you could have done multiplied by, as you could have done divided by 2 over 3. Sorry, I just need a little bit more space. So you had 2 over 3x equals 14. And what you could have done is you could have done divided by 2 over 3, right? Divided by 2 over 3. And then these two would have canceled each other out, so I wouldn't have had to worry about that. And it would have been x is equal to 14 divided by 2 over 3. When you divide fractions, you do 14, keep. So I'm just going to leave it as 14 over 1. Change the sign, flip the fraction. So what you would have done is 14 times 3, which would have been 42 over 2 equals 42 divided by 2 is equal to 21. Either way, you would have gotten the same answer. Okay, just depends on which way you feel more comfortable doing this. Alrighty, so again, if I wanted to left right check that, I'm just going to change my pen over to this one and give myself a little bit more space. I'm going to do the check at the bottom just to give myself a little bit more space. So I'm just going to say checking over here. Right? And in order to check, we're going to do the same thing. We're going to do left side, right side. So I already know that my right side is equal to 10. So I can just put that in. 10. And then I'm going to do the same thing. I'm going to do 2 over 3x minus 4. So 2 over 3x minus 4. So I'm just going to plug in my number for x, which is 21, and always put it in brackets, divided by 3 minus 4, right? 4 is over 1, so I'm just going to change this to over 3, so make it a common denominator. I changed by multiplying by 3, so whatever I do to the top, I got to do whatever I do to the bottom, I got to do to the top. So 4 times 3 is 12, right? And I'm just going to do 21 times 2, which is equal to 42 over 3. So I'm going to do 42 minus 12, which is going to give me 30 divided by 3, and that's going to give me 10. Right? And now left side equals right side. Therefore, statement is true. And that's it. That's the end of the lesson. I hope this helps. I'm going to post these solutions on D2L before we even do the lesson, but it's great for you to watch this video beforehand because it'll help you understand things a little bit better. Thank you. Have a great day.